Simply imagine what it would be like to live on planet Mars. The planet's surface is extremely hostile, but we are building settlements there. Forget everything you know about ordinary houses on planet Earth. There, the rules of physics and human survival are completely different and harsh. Today I will show you step by step how we build a base. The first major enemy we have to defeat is cosmic radiation. Mars does not have a protective magnetic field like our blue planet. Dangerous solar particles constantly and directly strike the planet's surface without stopping. Also, temperatures can drop to -100 degrees during the night. The atmosphere is very thin and full of highly toxic carbon dioxide. So how can we build a safe haven in this frozen hell? The crucial first step is choosing the perfect location for our future home. We cannot simply build anywhere on this vast red plain. An excellent option is hiding the base inside volcanic lava tubes. These deep caves offer great natural protection against deadly cosmic radiation. Another option is building near large deposits of underground ice. The ice will be essential for producing water and even breathable oxygen. Step 2 is sending autonomous robots ahead of the brave humans. These intelligent robots will prepare the ground and gather local resources. Bringing construction materials all the way from Earth is far too expensive. A single kilogram of material costs thousands of dollars to transport. Therefore, we absolutely must use what we find directly on Mars. The Martian soil, also called regolith, will be our main building material. The robots will excavate this reddish regolith and process it rapidly. By mixing the regolith with water, we can create very hard Martian concrete. Step 3 is the deployment of massive and highly advanced three-dimensional printers. These giant printers will use the Martian concrete to build sturdy walls. They will work tirelessly, day and night, building the base layer by layer. The structure will likely resemble a massive dome or a large sphere. The round shape distributes pressure perfectly and is highly resistant to storms. The concrete walls must have a thickness of several meters. Only this way can we effectively block lethal radiation from outer space. Under this concrete dome, we will install a second protective barrier. An inflatable habitable module will be brought in and inflated inside. This inflatable technology is already successfully tested on the space station. The module will keep the air breathable and the pressure at a normal level. Step 4 is the installation of complex human life support systems. The base must be a completely closed and highly efficient system. Every single drop of water will be recovered, purified, and constantly reused. Even sweat or moisture from breathing will be recycled immediately. Special generators will extract oxygen directly from the carbon dioxide-rich atmosphere. A similar device has already worked perfectly on the Perseverance rover. We need to build special access doors, known exactly as airlocks. These will stop the loss of precious oxygen when astronauts go to the surface. Moreover, they prevent toxic dust from entering the safe interior of the base. Martian dust is very fine, extremely abrasive, and actually quite dangerous. It can destroy equipment and severely sicken the lungs of our brave explorers. Step 5 is obtaining a constant and safe source of energy. Solar panels are good, but massive dust storms can easily block the light. A global storm can last for months, leaving the base in total darkness. For this reason, we need miniature surface nuclear reactors. These compact reactors will provide electricity regardless of the weather conditions. The energy will power the base heating, lighting, and all recycling systems. Without continuous electrical power, the mission would fail in just a few dramatic hours. Step 6 is ensuring food for our future colonists on Mars. Bringing food from Earth is not a viable, sustainable solution at all. Therefore, we will have to build hydroponic greenhouses inside our base. We will grow plants in nutrient-rich water without using Martian soil. The plants will provide us with fresh food and produce additional oxygen. Also, caring for plants has a beneficial psychological effect on the astronauts. Living inside an isolated base can be extremely stressful and demanding. The greenery will remind the crew of their beautiful home left on Earth. Now that we have the structure, air, energy, and food, the base is ready. The first humans can arrive directly in this environment, completely prepared for life. At first, only a few dedicated scientists will live there, but over time, the base will expand by adding other modules. We will connect these modules through completely safe and pressurized underground tunnels. A small scientific village will gradually become a true Martian city. However, the mental and physical challenges will remain enormous for the first colonists. Gravity on planet Mars is only 1/3 of Earth's gravity. This will inevitably lead to a rapid loss of muscle and bone mass. Astronauts will have to do intense physical exercises every single day. Also, the enormous distance from Earth will make communication very difficult. A simple message can be delayed by up to 20 full minutes. In case of a major emergency, the crew will have to solve the problem alone. But humans are incredibly adaptable and courageous creatures. Colonizing planet Mars represents the next great step of our human species. This achievement will make us a powerful and completely multiplanetary civilization. It will protect our future in the event of a global disaster on Earth. Every obstacle we overcome there helps our technology right here. Innovations developed for Mars will solve many of our terrestrial problems. The dream of living on another planet is becoming a reality right now. Who knows? Maybe even you will live on planet Mars someday. Thank you for your attention, and always remember to explore the future.